This is our project. We're project 89, and we concentrated on spam email detection. So our motivation was to detect spam emails because we believe it's important that these unwanted messages are filtered because they can harm, and like in today's digital world, they're very widespread. And our main motivation is for spam email detection are to protect from malicious content, and it's very time and resource efficient. Our methodology. Um, the inference tasks at hand are: one, we want to feature extraction, such as checking word frequency, presence of specific key phrases, sender information, and subject line analysis, which means we'll be looking at the content of the email, which will help us determine whether or not it's spam. We will then be applying different algorithms for modeling such um, as like neural networks. And finally, we'll be evaluating the model's performance using different metrics and decision making.
So the baseline model for our project would be a naive-Bayes classifier. In this case, the naive-Bayes classifier is a probabilistic model and uses the probability of the word occurrence in the emails to classify whether it is spam or not spam. So, as Josh explained, in our methodology, we would be doing certain feature extractions which have all the word count and the different words used, and those contain different pre-processing techniques such as removing the tense of the word so that we get the root word in order to train our models. So coming to the baseline results, so we'll be mainly using accuracy and precision as our metrics for the performance. So our baseline results for naive-Bayes model shows an accuracy of 88.97%, which is like a pretty good result for just the baseline. But in the digital world, I think we need like close to 100% accuracy because we need uh, protection from all these spam emails. So there was definitely room for improvement in this regards. So after doing a brief literature review, we were able to conclude that recurrent neural network was a better suited model for text-based classifications. So uh, because it has a memory component included in it, which would take into consideration the pattern of word appearance in each email, so that would help better train the model. So if you can see the results of the baseline of the actual neural network model is the accuracy is close to 99%, and we have the precision of about 98.66%, which is which is very good actually. And the precision tells us the number of proper spam emails detected among the total number of spam emails detected. And if you can look at the confusion matrix here, we can clearly see a distinction between the baseline model and the neural network model, and there are a lot less mispredictions happening in the confusion matrix. So, in conclusion, we can uh, see that a neural network model is way more efficient than a naive-Bayes classifier in this case, because the baseline just includes probability as a factor in the classification, whereas the neural network model uses deep learning methods. And since it has a memory component included, it better recognizes the pattern of the text. And here are the metrics used was just accuracy and precision, mainly because it was a binary output, that is either it's like a spam or not spam, and accuracy was the best performance metric that could be used. And so this is Satvik, and our teammates are Aditya and Josh, and thank you for listening.